What's up, everyone? Michael here with ShadowTraffic, and today we're going to be looking at modeling chains of events. If you're going to do any kind of simulation that's really non-trivial, a lot of the complexity comes down to not simulating a single event, but modeling a succession of events one after the other. And so the example I'm going to take you through today is something probably pretty familiar, which is a customer funnel. So maybe someone shows up to your website, they put some items in their cart, they look at their cart, maybe they add more items to the cart, and then eventually they check out and they purchase. And so what we're going to do is we're going to model that sequence of events to make sure that they happen one after another. And we're just going to dive in. And so like all the other examples, I've made a new file, I've gone ahead, I got the boilerplate for this one ready, and so it's going to generate to a topic called funnel events. And so the way we're going to attack this example is actually to model the life cycle of a single customer, and then I'm going to come back at the end and show you how you generalize this to run on many customers. I think it's one of the nicer parts of ShadowTraffic's API. And so, who's the customer? Let's just say we're going to store the customer in the key, and today the customer is just going to be named. We're just going to go with Fred. So Fred's our customer. All my events generated are for Fred, and I'm going to go ahead and dive into it. So the main way that we're going to model movement of events and sequences of events over time is with a primitive called state machine. So I'll go ahead and now define that up at the top. It goes to the root of your generator, and it's like anything else. You say I want to gen state machine. And there's a few parts to this. This is probably the most complex generator because it lets you do kind of the most sophisticated operations, but it's like a normal state machine like you would think of anywhere else. So what do you have in a state machine? You have an initial state, and so maybe our initial state is view landing page. And then where do you go from there? What are the states? How do you draw the lines? You specify that with transitions. And so what are the states that could happen here? I think I mentioned, so we'll start with view landing page is the obvious one. And then what would they transition to? Maybe they'll add item to cart. And then you could do a few things after you add your item to cart. Let's say maybe you could view the cart, you can add more items. And so you could put a generator here and say, pick from things. So gen one of, and then what are your choices? Maybe the choices are, as I said, view cart or add item to cart. And then maybe the last one will be just view cart, and then we'll leave to checkout. And so this sort of shows, it draws sort of what are the transitions across the state machine. And so the last thing that we'll supply are the actual states themselves. And for this one, I'm just going to copy in all the code so that you don't have to watch me do it. And I'll explain how this works in just a second. So I'll do states and copy that down. And what happens is when you specify the states, you make a map and you name every state. And then you give it a map to merge into the main generated record. And so we're generating keys and values with Kafka, and so we're gonna populate the value side of the record. And so for landing page, we're gonna give it for viewing the landing page, we're gonna mark the stage name, and then we're gonna generate a URL. For creating adding items to your cart, we're gonna create product names, and so on and so on. And so if I save that, what I'll see is an error, and so I misspelled state machine. So state. You were watching that video and you wanted me to correct it so badly, and I didn't see it till the end. So here's what I have. I have events for Fred. He goes to the landing page, he adds an item to his cart, he checks out, and then the state machine repeats again. And so this is great. This actually just works for a single customer. I might want to make this a little bit more realistic and add some pausing in here. It's not probably the case that Fred is rapid firing moving to the website, so maybe local configs. I'll add throttle, and maybe just for the sake of keeping it really easy, maybe every 800 milliseconds Fred's gonna transition through a new stage, and here you start here you start to see kind of a more lag. It's moving at a bit per second, and so this is great. We've modeled kind of this succession of events for Fred, but what we want actually is to model this for many different customers at the same time, and that's where this additional feature called fork comes in. Fork says, take this generator and dynamically clone it based on some value to sort of parallelize it. And so the value we're going to parallelize along are the customers, not just Fred, but for many different customers. And so with fork, you give it a key, and the key is just the value to sort of maintain the identity of every fork. And so instead of Fred now, we're just going to say, we're going to give it a generator. So gen string, and the expression here is going to be, we'll say the name, username. And so that, I'll just back out of this key anymore. So I don't really need that at the moment. So I have my fork set up. And now what I need is to actually say not just where what location the funnel is in, but who is the current customer inside of the funnel. I don't have it anymore. It's not Fred. It's some random user string. And the way that I get access to that is with a variable. When I use forks, I get a variable free called fork key, which is literally the value that is generated in this expression. And so just before I run that, I want to do one more thing. I'm going to add a little parameter called stagger. And this is just like throttle, but for fork. And so it tells it how quickly am I going to make new forks, which in the example that we're talking about, this says every 200 milliseconds, generate a new customer and then run everything else. And so I'm maybe generate Mary is the next user. And so fork key will be supplied with Mary, and that customer will be transitioned through the state machine at rates of every state per 800 milliseconds. And so if I run that, now I see more different customers. I'm gonna extend this out to do 50 samples, and then I'm gonna try to just sort of parse what's going on here. And so now every 200 milliseconds, I'm getting a new customer, and now I see Jonas, I see Don, I see Sergio, and as I walk through all these, every 800 milliseconds, I'm gonna watch each of these users transition to the next phase. And that is how you model chains of events. This fork operation allows you to create dynamic parallel copies of generator without having to actually go in and type in all these usernames. And it's even more than that. Because you couldn't even come up with all these usernames yourselves, you kind of want these flowing in over time. It's able to tap into the dynamism of ShadowTraffic and just parallelize all these things for you. And so it's a really powerful feature, worth walking through the docs and getting yourself familiar. So thanks, and looking forward to recording the next one.